Hello everybody. In this video we're going to learn how to find concavity and point of inflection. Points of inflection is the point on the graph at which the second derivative is equal to 0 or undefined. We find the second derivative because second derivative is the tangent line to the graph. And if the tangent line has positive slope, then we have concave up. If the tangent line has negative slope, then we have concave down. Here our first step is to find the second derivative. So our f prime of x will be negative 3x squared plus 4x. And derivative of the first derivative will be our second derivative, which is 6x plus 4. Now we're going to set the second derivative equal to 0 to find our critical x value. Negative 6x plus 4 equal to 0. From here we solve for x as 2/3. And if we plug 2/3 in our original function, we find the y value. Here we obtain 43 over 27. So our inflection point is 2/3, 43 over 27. And it is roughly here in the graph. Let's test it out whether it is our inflection point or not. Our critical x value is 2/3. Now we're going to pick up a value on the left and on the right of 2/3. Let's pick 0 here and let's pick 1 here. Now we're going to plug in these values on our second derivative. So f double prime of 0 is equal to 4, so this is positive value. So we have positives on here. And our f double prime of 1 is equal to negative 6 plus 4, which is negative 2. And that is our negative value. As we can see, from positive to negative, that's our inflection point. So our concave up is equal to from negative infinity up to 2/3. And our concave down is from 2/3 to positive infinity. And 2/3 is the inflection point, so it is not inclusive. Let's go ahead and see the second example. Our second example is x to the 4th minus x to the 3rd minus 3x squared plus 4. First, we're going to find the first derivative. Derivative of x to the 4th is 4x to the 3rd. Derivative of x to the 3rd is 3x squared. And derivative of 3x squared is 6x. Now we're going to find the second derivative. So we obtain 12x to the 2nd minus 6x minus 6. Now we're going to set our second derivative equal to 0. Here we have a quadratic function, so we need to solve this quadratic. First, we divide everything on 6, so we obtain x squared minus x minus 1 equal to 0. Here, using the AC method, we obtain x minus 1 times 2x plus 1. Setting each factor equal to 0, we obtain x equals to 1 and x equals to negative 1/2. So those are our critical x values. Negative 1/2 and 1. And we're going to test out those zones. We can pick up 0 here, we can pick up 2 here, and we can pick up negative 1 here. Now we need to find the y values of those critical x values by plugging these values in our original function. So f of 1 and f of negative 1/2. So 1 to the 4th minus 1 to the 3rd minus 3 times 1 squared plus 4. So this is going to be equal to 1. So our first inflection point is 1, 1. So this is our first inflection point. And our second inflection point will be negative 1/2 to the 4th, negative 1/2 to the 3rd, 3 times negative 1/2 squared plus 4. And this is equal to 55/16. So our second inflection point is negative 1/2, comma 55/16. And that is roughly equal to here. Now let's test out whether it is the inflection point or not. So we're going to plug 0 on our second derivative. If we plug in here 0, we obtain negative 6, so this is our negative zone. If we plug in negative 1, this is going to be positive, and we obtain positive zone here. And if we plug in 2, we again obtain positive. So actually those are our inflection points: concave up, concave down, and concave up. So our concave up will be negative infinity up to negative 1/2. Negative 1/2 is not inclusive because it's the inflection point. Union 1 to infinity. And our concave down is negative 1/2 up to 1. I hope these examples gave you idea on how to find points of inflection and concavity. If you come across a problem that you can't solve, please send it to me and we can work on it together. Thank you for watching.